Okay, quadratic formula. Let's get it. Okay, number one, x squared plus 12x plus 32 equals 0. We're going to plug it into, so the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so there's the formula we're going to use. My a, my b, my c. Start plugging and chugging. So let's plug these numbers into that formula. So negative b, 12, plus or minus 12 squared minus 4 times a, which is 1, times c, which is 32, all over 2a. In this case, right, 2 times 1 is just 2. Okay, do a quick little analysis of the discriminant, the part inside of the square root. This will tell us how many answers we should expect to see. So 12 squared is 144 minus 32 times 4. 4 times 2 is 8. 4 times 3 is 12. So this is going to be a positive number for sure. So 144 minus 128. This is 8, 9, 10, 11, 12, 13, 14, 6. 1, so 16. So the discriminant is positive. Right, it's positive. So that means I'm going to have 2 roots, real roots. So negative 12 plus or minus the square root of 16, which that's nice because that's a perfect square. So negative 12 plus or minus 4 over 2. So negative 12 plus 4 would be negative 8. Negative 8 divided by 2, it's negative 4. And negative 12 minus 4 would be negative 16. Again, divided by 2, that's going to be negative 8. So my two answers are x equals negative 4 and x equals negative 8. So remember what we're finding, right? The solutions to this problem where this graph, which is quadratic, crosses the x-axis. So we see that it crosses, if this is the x-axis, it crosses in 2 spots, negative 8 and negative 4. Those 2 spots, that's what's happening. Right, so a quick analysis of what the discriminant is doing. This part inside, right, there are 3 scenarios. This value is going to be positive, which we get 2 roots when it's positive, right, point in case. Or this value is equal to 0 and we'll have 1 root. Or it's a complex number, meaning there's a negative value inside and we don't get any real roots. However, we'll get 2 imaginary roots, which we'll see coming up. So this is number 1. And number 2, x squared plus 4x plus 1 is equal to 0. A is 1, b is 4, c is 1. Plug into the quadratic formula. We're going to get negative b plus or minus square root 4 squared minus 4 ac, so 1 times 1, all over 2a, 2 times 1. Okay, quick look at the discriminant. We're going to get 16 minus 4. So 16 minus 4 is 12. That's a positive number. The discriminant's positive. So we're going to get 2 roots. We're already expecting it. 2 roots. So let's go. This is going to be negative 4 plus or minus root 12. root 12 can be rewritten. So 12 is 4 times 3. So I'm going to pull out a 2. 2 root 3 all over 2. Okay. Right, this is x equals. And this is basically the answer. We can simplify it. So notice this term, and this term. So 2 terms on top, 1 term on bottom. All have a coefficient that's divisible by 2. So 2 goes into 2 once. 2 goes into 4 twice. 2 goes into this 2 once. So my 2 roots are going to be negative 2 plus or minus root 3. All right, number 3. X squared minus 2x plus 5 equals 0. A, B, C. So A is 1, B is negative 2, C is 5. So negative 2, so minus negative 2. Right, this minus comes from the equation. This negative sign comes from the value here. Plus or minus square root negative 2 squared minus 4a, which is 1, c, which is 5, all over 2a. Okay, let's see what happens here. 2 squared, negative 2 squared is going to be 4, minus 4 times 5, which is 20. So we're going to get negative 15. So here we have our first instant that the discriminant is negative. Right, the discriminant is negative, smaller than 0. This tells me I'm going to have 2 imaginary roots. Right, my answer is going to have I in them. So it's simplifying. So negative and negative, that's math for plus, basically just positive 2, plus or minus square root negative 15 all over 2. Okay. 15, 3 times 5, I can't take anything out. This 2 cannot cancel with that 2 because there's no coefficient here that is divisible, right? So I can't just cross these out. It doesn't work that way. So the answer, x is going to equal 2 plus or minus root 15 I. It's imaginary, right? Because this negative sign comes out as I over 2. Okay, number 4. X squared minus 2x equals negative 5. If I add 5 to both sides, I'm going to get x squared minus 2x plus 5, which is the same as number 3. All right, number 5. 42 plus x squared minus 12x. Okay, so they're trying to throw us off here by mixing up the numbers. So if we put them in descending order, right, x squared, x, and then the constant, we can move 42 over, right? But we're smarter than that. So this is my c value, this is my a value, this is my b value. So let's plug in to the quadratic formula. So negative b, in this case, is going to be minus negative 12 plus or minus square root negative 12 squared minus 4 times a, which is 1, c, which is 42, all over 2a. A is 1. Okay, quick discriminant check. We got 144 minus 42 times 4. So 4 times 2 is 8. 4 times 4 is 16. It's definitely going to be negative. So this is going to be, what is that? 20, 22, negative 22. Seems about right. Like if I add that here, 60, no, 24. Negative 24. Okay, simplifying, we got 12 plus or minus square root negative 24 over 2. 24 can be rewritten. First off, it's negative, so I is going to come out. And then this is going to be 4 times 6. I can pull a 2, pull out a 2, and this is 2 times 3, so 6 will just be left over. So this is going to be 12 plus or minus 2 root 6i over 2. This value up top, these two values are both divisible by 2. So 1, 1, 2 goes into 12 6 times. Final answer, x is equal to 6 plus or minus root 6i. Oh, I forgot to do the discriminant, right? Well, it was negative 24. So we know that the discriminant is less than 0. So we're going to get 2 imaginary numbers. And we saw it. 2 imaginary roots. Okay, number 6. 2x squared plus 7 minus 11. So A, B, C. Negative B, which is 7, plus or minus square root 7 squared minus 4a, which is 2, 11 for our c value, negative 11, all over 2 times a, which is 2, or which is 4, 2 times 2. Okay, let's check the discriminant out. So this is going to be 49 by 7 times 7 plus, right, because negative, negative, plus. This is going to be 2 times 4 is 8, times 11 is 88. All right, so it's a positive number, bigger than 0. So 2 roots, real roots. What's 49 plus 88? 9 plus 8, 17, carry the 1. 8, 9, 10, 11, 12, plus 1, 13. So 137. 17, carry the 1. Yep, 137. Simplifying, negative 7 plus or minus root 137 all over 4. Let's see. 137, is that a prime number? It's not divisible by 2. Can we factor something out? I don't think we can. Even if we could factor something out, it wouldn't even matter because 4 and 7 aren't. 7 is a prime number, so I can't take anything out anyway. So let's just go with that's it. Okay, number 7. 0.4x squared plus x equals 0.3. Okay, all these decimals, I don't like that. So I'm going to multiply everything by 10, which is basically going to move the decimal. Here, we'll turn to 10, and then this will be 3. I'm going to subtract 3 from both sides. So if I subtract 3, it's going to be equal to 0. This is how we're able to apply the quadratic formula, right? So this is my A value, B value, C value is negative 3, 4, 10, negative 3. Okay, negative B, which in this case is 10, plus or minus square root 10 squared minus 4a, so 4c, negative 3, all over 2 times a, so 2 times 4. Checking the discriminant, we have 100 minus, here's the negative, so it's going to make that a plus. 4 times 4 is 12, times 3, 36. Right, 16, oh wait, 4 times 3 is 12. 12 times 4 would be 48. Almost got me. Okay, this is going to be 148. which is a positive number. Discriminant's positive, obviously, and that means 2 real roots. 2 real roots. See what those roots are. So I got negative 10 plus or minus square root of 148 all over 2 times 4, which is 8. Okay, 148 can definitely be simplified. So 148 divided by 2. If I did 4, I can get there faster. So this would be 3, 7, right? 4 goes into 14 3 times, which is 12. 14 minus 12 is 2. 2 bring down the 8 is 28, so it's 37. 37 is a prime number. That's nice. So I'm going to pull out a 2. So x is equal to negative 10 plus or minus 2 root 37 all over 8. So I'm going to take out a 2 here, leave behind 4, take out a 2 here, leave behind 5, and 2 just goes away. So final answer, my 2 roots, my 2 real roots are going to be 5 plus or minus root 37 all over 4. Number 8, x squared plus 16 plus 4. So A, B, C. Okay, negative 16 plus or minus square root 16 squared minus 4, A, which is 1, C, which is 4, all over 2 times A, which is 1. Okay, discriminant 16 squared, what's that? So 256 minus 16 this is going to be 246, 240. So it's a real number. Actually, it's a positive number. So I'm going to have 2 real roots. We might as well go ahead and start thinking about simplifying it. So this is going to be 60, 4 times 60. This is going to be 246. So 2 times 30, which is basically 2 times 15, and that's 3 times 5. So I'm going to pull out a 2 here. I'm also going to pull out a 2 here, and 15 will be left behind. So what am I saying? I'm saying minus 16 plus or minus, I pulled out basically a 4, root 15 all over 2. Okay, even number, even number, even number. So 1, 2 goes into 16 8 times, 2 goes into 4 twice. So x is equal to negative 8 plus or minus 2 root 15. Okay, number 9. 4x squared minus 20x equals negative 25. So we're going to add 25 to both sides. And this is my A, this is my B, this is my C. Okay, let's get it. Minus negative 20 plus or minus square root B squared, so negative 20 squared, minus 4A, which is 4, C, which is 25. It's going to be a big number for sure. And this is 2 times A, which is 4, so this will be 8 eventually. Okay, let's look at the discriminant. Negative 20 squared, so it's 400, minus 4 times 25 is 100, times 4 is 400. Well, look at this. 400 minus 400 is 0. Since the discriminant is 0, right, it's equal to 0, this means we have 1 real root. Let's see what that root is. Simplify, negative, negative, positive. Plus or minus the square root is 0, so I'm not even going to write anything. All over 2 times 4, which is 8. Okay, this is going to be 20 over 8, which is 10 over 4, which is basically 5 over 2. Okay, right? So this means that x is equal to 5 halves. Right, here's our quadratic, and the x vertex is at 5 over 2. Right, this is the x-axis. It's sitting at 5 halves. Number 10. So maybe let's move the negative 3x squared this way. So we're going to get a positive 3x squared plus 6x minus 10 is equal to 0. Well, I could move all these this way, but I'd rather move one thing as opposed to moving two things. So, and not only that, but it keeps a positive, which is always nice. Less negative, the better. Okay, A, B, C. One thing I noticed, I was about to say we could factor out some things, but we can't. So let's just go straight to the formula. Negative b, which is 6, plus or minus square root 6 squared, minus 4 times a, which is 3, times c, which is negative 10, all over 2a, 2 times 3. Okay, discriminant check. 36 minus times that negative is plus, and then 4 times 3 is 12, times 10 is 120. This is 156. So discriminant is positive, so 2 real roots. Let's see what they are. So this is going to be negative 6 plus or minus square root of 156 all over 6. Okay, so let's simplify 156. So 4, let me use 4. 4 goes into 15 3 times. So that's 12, 13, 14, 15. So 36 would be 9. Right. That's not right. So 4 goes into 15 4 times. No, 3 times. Oh my goodness. 156. 4 goes into 15 3, which is 12. 36, which is 9. Oh, 39. What was I thinking? 39's 3 times 13, so you really can't do anything. All we can pull out is a 4. So this is going to be negative 6 plus or minus 2 root 39 all over 6. Even numbers, here, here, and here. So 2 goes into 6 3 times. 2 goes into this once. So our two answers are 3 plus or minus root 39 all over 3. It almost seems like this could cancel, right? But don't fall for it. It cannot. Okay. Couple things. We could use a perfect square if we wanted. We haven't done that in a while, so let's try that. So 16 is a perfect square. That means 4 squared, x squared minus 1 is really 1 squared. The square can get factored out in a sense. Okay, so basically what I'm doing is a squared minus b squared, a minus b, a plus b. Now I'm applying this, right? This is what we have. So this is my a, this is my b. So I can rewrite this into 4x minus 1, 4x plus 1 is equal to 0. Set each of these equal to 0, right? Because two things being multiplied equals 0, one must be 0. So where do they equal 0? So this is going to be 4x minus 1, which is basically add 1 to both sides. 4x is equal to 1 divided by 4 divided by 4. So x is equal to 1/4 on this side. And here, 4x plus 1, be the same thing but negative. So x is equal to negative 1/4. Again, you don't have to do it this way. You could do it another way, but this is the way I wanted to do it. So it's not bad. Number 12, x squared divided by 20 plus 8 equals negative 15. First thing I'm going to do, subtract 8 from both sides. Combine like terms. I want to combine the like terms. Could I have brought the negative 15 this way by adding? Yeah, I could have. So this is going to be x squared over 20, negative 15 minus 8. So it's going to get even bigger. So it's going to be negative 23, right? 8, which is 5 and 3, so 23. I'm going to multiply everything by 20 because I want to clear the fraction. So this is going to be x squared is equal to negative 2 times 23, 46, plus a 0. It's negative. So x squared, since I isolated it, take a square root of both sides. X is equal to plus or minus, right? Because I introduced the square root. There's a negative, so that's going to come out as I. So I, square root 460. This can be simplified. So 20 and 23. 23 is prime. So 4 and 5. So I could pull out a 2, basically. So final answer, x is equal to plus or minus 2 and the product of 5 and 23. So 5 times 3 is 15, carry the 1, 10, 11. So root 115i. X is equal to plus or minus 2 root 115i. Those are the two roots. Okay, number 13. 4 times x minus 1 squared equals 8. All right, I want to solve for x. Divide both sides by 4. So x minus 1 squared is equal to 2. I want to unlock the x, right? So I have to take a square root. So x minus 1 is equal to plus or minus root 2. I add 1 to both sides. So x is equal to 1 plus or minus root 2. That one's fun. Square root method is, it's nice when it comes up. All right, number 14. 4x squared minus 20x plus 25. Can't factor anything out. Definitely don't want to complete the square. Let's just use quadratic formula. So A, B, C. So negative 20 plus or minus negative 20 squared minus 4A, which is 4, C, which is 25, all over 2 times 4. I feel like we've seen this before. Right? Because this is going to be 400 minus 100. This is 400. This is 0. Discriminant 0. Yeah, we had this problem. That's odd. So, well, it's nice. So this is going to be 20 plus or minus 0 all over 8. which is 5/2. So x is equal to 5/2. It's nice when that happens. Okay. Can't use the square root method here. Actually, number 15. 4 times x minus 1 squared equals 6x plus 2. So we can't use the square root method here because of this x term right here. I could factor out a 2 from everything, but that doesn't do me any good. So instead of just thinking, let's just push through with the quadratic formula. However, I'm going to need to do some expansion. So this is going to be some expanding. So 4 times squaring a binomial. So if you remember, x times x, x squared. 1 times 1 is going to be positive 1. And then 2 times x times negative 1, which is basically negative 2x. Right? 6x plus 2. Can't combine like terms just yet. I have to distribute. So 4x squared plus 4 minus 8x is equal to 6x plus 2. Move everything to left. So minus 2, minus 2, minus 6x, minus 6x. So we're going to get 4x squared plus 2, right? Positive 4 minus 2 is 2. This is going to be negative 14x, right? Because 8 plus 8 would be 16. This is 2 less, so 14x, which is equal to 0. It's out of order, but that's okay. We're smart. We can figure this out. So this is going to be A. This is going to be C, the constant, and this is going to be B, which is negative 14. Okay, let's push through. This is going to be minus B, which is negative 14, plus or minus square root negative 14 squared, minus 4A, which is 4, C, which is 2, all over 2A. So 2 times 4, which is 8. All right, let's simplify. Actually, let's work out the discriminant. 14 times 14, what's that? 169 is 13 squared. So 13 squared, 169, plus 14, plus 13. So plus 27. So 169 plus 27. 6, 6, 7, 8, 9. 196, that sounds right. All right, so this is going to be 196 minus 4 times 4 is 16 times 2 is 32. So 164, that's the discriminant part. So we got positive 14 plus or minus root 164 all over 8. All right, 164, that can be broken down into, so 4 will go 41. All right, 4 goes into 16 4 times. Then 4 goes into 4 once. So I'm going to pull out a 2. So this is 14 plus or minus 2 root 41 over 8. Looking at all our even numbers, even. So 2 goes into 8, 4, 7, 1. So x is equal 7 plus or minus root 41 all over 4. Right, so this, quadratic formula isn't always ideal, right? It's definitely a longer method. It's the method I chose. Sometimes you spend a lot of time trying to figure out what the shortest way is, and then you end up just doing the longer method and getting there just as fast. So Okay, number 16. 7x squared minus 10 equals 25. All right, there's no x term, so square root method is the preferred method. 7x squared, I'm adding 10 to both sides, so this is going to be 35. This is nice, right? Number sense, I know this is divisible by 7, so x squared is equal to 5, right? Because 35 divided by 7 is 5. Taking the square root, x is equal to plus or minus root 5. That's nice. I like the simple ones. Number 17, 7x minus 3x squared equals 85 plus 2x squared plus 2x. So let's start combining like terms by moving everything to one side or the other. There's more things on that side, so I'm going to start moving things this way. So I'm going to add 3x squared to both sides. I'm going to subtract 7x minus 7x, and this will all be equal to 0. So we're going to get, here I'm going to write it in descending order. So this is going to be 5x squared. This is going to be negative 5x plus 85 equals 0. Look, 5, 5, 5. So let's go ahead and divide a 5 out. Divide everything by 5. So this is going to be x squared minus x plus, what is this? 5 goes into 8 once. 5 goes into 35, 7 equals 0. Okay, can't do anything here. I thought maybe we could just factor it the old-fashioned way, right? But factors that multiply to make 17. 17 is prime, so just 1 in 17. There's no way to make a 1. Okay. Quadratic formula it is. What about completing the square? Let's try completing the square. Only because, oh no, if I take half of 1, I'm going to get 1/2. Let's not do that. I don't want to go down the road of fractions. Let's just quadratic formula. So A, B, C. So minus negative 1 plus or minus negative 1 squared minus 4a, which is 1, c, which is 17, all over 2a. So this is going to be discriminant first. So positive 1 minus 4 times 17. So 4 times 7 is 28. Carry the 2, 4, 5, 6, which is basically negative 67. So simplifying, we have 1 positive, right, because negative and negative, plus or minus root negative 67 all over 2. 67, is that a prime number? It's not on my multiplication tables. So we can pull out an I for the negative. So x is going to be equal to 1 plus or minus root 67 I all over 2. Okay, number 18. 14x squared minus 21x equals 0. I think we can factor out a 7. So this is going to be 2x squared minus 3x is equal to 0. Gets a little bit better. There's an x common to both. If I factor out an x, I'm going to get 2x minus 3 is equal to 0, right? X times this gives me that. X times this gives me that. So we're just factoring out an x. I want to set both of these equal to 0, right? Because I'm multiplying two things that equal 0. One must be 0. So when x is equal to 0, oh, that's nice. That's one of my roots. 2x minus 3 is equal to 0. So I'm going to add 3. So 2x is equal to 3. Divide both sides by 2. And x is equal to 3/2. Those are my two answers. X equals 0 and x equals 3/2. That one looked scary at the beginning, but it actually worked out really nice. It worked out really nice. Okay, number 19. 16x squared minus 7x equals 17x minus 9. First thing I'm thinking is I want to move everything to one side. Let's move everything to the left. So minus 17 minus 17x. This is, and then add 9. Add 9. So this is going to be 16x squared minus, both of these are negative, so it's going to get even bigger. 17 plus 7, 24. X plus 9 is equal to 0. Right, everything moved to the left. It almost seems like something could factor out of these, but it cannot, right, because of the 9. Okay, giving it enough thought. Quadratic formula, don't waste any time. So A, B, C. Okay, this is going to be negative 24 plus or minus square root negative 24 squared minus 4a, which is 16, and then 9. Okay, all over 2a, 2 times 16. Okay, what are we thinking? 24 squared, right? 25 squared is 625. So minus a row, minus a column. So it's going to be 625, 600, 600 minus 24, 576. So 24 squared is 576. Then I'm going to do, what do I want to do? 4 times 9 times 6. So this is going to be 30 minus 36 times 16. 36 times 16, 6 times 6 is 36, 9, 10, 11, 12. This is going to be 1 times 6, 16. No, 1 times 6 is 6. 1 times 3 is 3. So 6, 8, 4. 486 minus 486. 576 minus 486. It's a positive number. That's a good thing. We're going to get 2 roots. So 0 is going to be 9. So 90. That's kind of nice. It's kind of nice. So simplifying, this is going to be 24 plus or minus root 90 all over 32. Okay, root 90. This can be split up 3 times 30, which is 3 times 10, which is 2 times 5. So a 3 is going to come out, 10 left over. So we got x is equal to 24 plus or minus 3 root 10 all over 32. Can't factor anything out because 32 is not divisible by 3. So there are my 2 roots. Okay, number 20. X squared minus 3x plus 5 equals 0. Two numbers that multiply to make 5 that add up to 3. Nothing. Okay, let's just hit it with the quadratic formula, I guess. So this is going to be negative 3 minus negative 3 plus or minus root negative 3 squared minus 4a, which is 1, c, which is 5, all over 2 times a, which is 2. Or a is 1, 2 times 1 is 2. Okay, discriminant 9 minus 20 So this is going to be, it's obviously going to be negative 11. It's prime, so I can't factor anything out. I'm going to have to pull out an I, right? This is going to be two imaginary roots. Okay, so I got simplify here. That's 3 positive plus or minus square root negative 11, so 11i all over 2. It's my 2 roots. Okay. 21 through 26, those are some concept knowledge questions. I'll let you figure those out. Other than that, hope this helped. Be sure to like and subscribe.